Okay, this is using data tables to find derivatives. And so in our we have our data table, and it says that water is flowing into a tank over a 24-hour period. The amount of water, which is represented by the function WT, at various times is measured, and the results are given in the table below, where WT is measured in gallons and T is measured in hours. And at time equals 0, there are 150 gallons of water. So we may need to know that at some point, that at time equals 0, there are 150 gallons of water. So tells us at different times. See, it tells us right there at time equals 0, we start with 150 gallons. It's in the table too. Maybe they started, you'll have some where it may give you that initial amount, but maybe they didn't start measuring until 5 hours in. But there's a reason that you're given that initial amount usually. All right, so it says, use the data from the table to find W of 8 and explain the meaning of your answer. Okay, that's a very simple question. What does W of 8 mean?
When T is 8.
Okay, at 8 hours.
Water is 221 gallons.
Okay, when time is 8 or at 8 hours, there are 221 gallons of water. Now you have enough room there that you can write out a good answer. Doesn't have to be lengthy, but it says explain what it means using units. So you need to be sure to talk about hours and gallons. I don't know that just T equals 8 would be sufficient. T equals 8 hours. Or at 8 hours, there are that many gallons of water in the tank. Okay, so that one is done. You've got your sheet. Now we're fixing to lose the data from my screen, but you've got your sheet you can look at.
Yes.
Pardon? Because it's going to move off. Okay, use the data from the table to find, what does that mean?
It's 1 over inverse.
Inverse. Inverse. What is inverse? What does that mean?
1 over.
Not necessarily 1 over. What happens with inverse functions?
Opposite.
Well, basically what that means is you're trying to find the hours when the gallons are 257.
Okay, that's exactly what that means. You're trying to find the number of hours, but with inverse functions, remember the x and the y change places. I would appreciate it if you all do not just get up and leave the room. So, what data, what does this mean to us?
At 200, there are 257 gallons of water.
Okay, there are 257 gallons of water when T equals 12 hours. So, those two are pretty easy. But if we hadn't talked about it, many of you might not have remembered what this means. Okay, this says use data from the table to find an approximation for W prime of 15 and show the computations that lead to your answer. Explain what your answer means. Okay, so what does W prime of 15 mean to us? It's a derivative. Do we have, how would we find that derivative from the data that we're given? It's a rate of change. when time is 15. Do we have anything about time being 15? How do we find rates of change from data points?
Over.
Say that again. You're close.
I said B minus A.
That's the derivative of B
Can you
minus
take
A
the
over
derivative
B
of
minus
2
A?
points?
All right. What did we say when we first started talking about what a derivative is?
It's a slope.
It's a slope. If you have data points, if you have two sets of data points, can you find the slope between those two sets of data points?
Yeah, so you go through 12 and 16.
Okay, so if we want to find W prime of 15, we probably want to look at those two data points. Now let me show you how you need to show this. All right, so here, what we're going to say is W at 16 minus W of, here it is, 12 over 16 minus 12. I would always show this statement because that way if you go pick up a wrong data point, this statement shows you knew what you were doing. You just read the chart wrong. So this needs to be shown, and then you can plug in the actual values. 294 minus 257 over 4, and that is, let's see, this is D, 37 fourths. Okay, now what does that mean to us? What is this? What is W prime of 15? It's a rate of change. What's changing? The water. Okay, so it's asking us to explain the meaning of our answer. So if this was like a 3-point thing, you'd get a point for this and a point for the correct answer. Gallons per. Okay, and so it means at time equals 15 hours, water is flowing into the tank at a rate of, you need to talk about a rate, they're probably looking for the word rate, of 37 fourths gallons per hour. Okay, so you need to have the word rate in your explanation because that is a rate of change. It's the rate at which water's flowing into the tank at 15 hours. So these would probably be the two things they'd be looking for at 15 hours and rate. You've got to be able to explain what our answers mean. These are not hard. You just have to show your work.
So you only want the rate of the answer, you don't want like what it would be? Like an approximation for what it would be? Just looking for the rate?
Yeah, W prime of 15, yeah.
But wait, you need to know
What else would we need to know?
approximation for, yeah.
Okay, if you wanted to, you could put W prime of 15 is approximately, but they're not, I don't think they'll be that picky. As long as you show this, you've got your answer, and you just explained what that means. That's the rate at which water's flowing into the tank. 37 fourths gallons per hour.
If you're finding the rate, not how many gallons. There's so many.
It's a rate of change. It didn't ask us for how many gallons. It's just the rate of change, approximately.
But isn't 37 fourths exact?
Not last time I checked.
But like,
It's 9 1/4. You could do 9.25.
That's an exact answer.
That would be an exact answer, I guess. Yeah. Yes, you're right. But yeah, because this may or may not be calculator active. Don't take that time. But yes, I'm sorry, you're correct. All right. Use data from the table to find the average rate of change over the time period from 4 to 20 hours and show the computation that leads to your answer.
Isn't that the exact same thing?
So the B minus
It's the same thing. A rate of change is that slope formula that we have used since Algebra 1. So you want to show W of 20 minus W of 4 over 20 minus 4. Be sure you show that. And then you can plug in the actual values. And that is approximately
47 force.
9375.
always go ahead and add units of measure, gallons per hour. Okay, any
Can you explain that one?
It didn't ask us to, so. All right, now the extra sheet I gave you should have printed on the back side of this front sheet. It did not, so. It says for between 0 and 24 hours, must there be a time when the tank contains 265 gallons of water? Justify your answer. How do you know?
It goes from 150 to 375.
Okay, so let's see how we justify that.
We
That would
need
meet
that-
their standards.
We need to do that formula right here.
Okay, so,
Could we take the one that we already did?
well, that's a rate of change. We've looked at that. Now, yes, it does.
Remember when we had to prove, like, they went
Do you
over
remember-
the car speed limit at this point?
That is the mean value theorem.
Yeah.
This would be the intermediate value theorem.
Okay.
Okay, by the intermediate value theorem, and you can abbreviate by the IVT, is that such a common theorem that's cited. So you need to specify by the IVT. This is a, well, it wouldn't hurt to say, let me take that off. Function is continuous. Okay, by the intermediate value theorem, W of 4 equals 184, which is less than 265, which is less than 357, which equals W of 25. Yeah, W of 0. Thank you. So let me change that. But because it did ask for 0. I was thinking about the previous problem.
But what does the W say? Is it W? Like,
W of 0. W of 0 is 150, which is less than 265, which is less than 357, which is W of 25. So that's your proof that, yes, at some point in time it had to contain 256 gallons of water. Okay, we mentioned that the function's continuous, and the intermediate value theorem guarantees that that's the case because of this information. So they're going to be looking for the intermediate value theorem and that you justified it right here. Okay. Not hard, but these are things that we've not talked about recently, so it's a good idea to come back and talk about them. And I don't want you getting worried just because you see tables, data tables. Let's look at this. A model for the amount of water in the tank, somehow they came up with a regression. And it's given by this equation. A of T is measured in gallons and T is measured in hours. So we had data, and from that data they were able to come up with this equation. They're giving it to you. You didn't have to come up with it. We want to find A prime at 15. So what are we going to do? Take the derivative. So A prime at T, go ahead and state what the derivative is 1 over 225 times negative 3t squared plus 60t plus 1800. There would probably be 1 point awarded for that. And then A prime of 15, you just plug it in. So what is A prime of 15? 9 gallons per hour. Do not forget to put your units of measure. Nine. That one came out exactly, I believe. Okay, so let's see the difference between F and G. G is asking us to find the average rate of change over the time period using A of T. So how do we go about doing that?
Integration.
Okay, we don't have to use integration here. Average rate of change. So it's going to be A of 20 minus A of 4 over 20 minus 4. If you see rate of change, think slope formula. Average value is integration. Average rate of change is slope formula. Okay, and average rate of change, you don't use the derivative function, you use the original function. So in this case, you probably would have a calculator, plug in A of T into Y1 of your calculator, and then it's easy to calculate A of 20 and A of 4.
So you just have in Y1 and then the number next to it?
Yes, Y1 with parentheses of 20 minus Y1 of 4, and then hit enter and divide it by 16. So what do we have? Has anybody gotten it yet?
Put it in our Y1, is that what you said?
Put it in your Y1. Put A of T, not the derivative. Because we're looking for average rate of change, which means we go up 1 from the derivative. Hopefully this is what you get.